we're going to measure the optical density of our culture using a spectrophotometer. So here's our cuvette that we're going to use to put the culture into. I'm going to make a dilution of culture in here actually. Note that there's a right and a wrong way to hold it, so you want to hold it by the sides that are not in the light path, and we'll talk about this again in a moment. So we're going to take 950 microliters of LB broth, and that's going to be used to dilute our culture down to a level that can be read by the spectro. This particular spectrophotometer doesn't actually have a wavelength setting, it's always set to 600 nanometers. But other spectros, you may need to first check that the wavelength is at the right setting before you actually put your sample into the machine. So holding it by the right sides, we gently pipette our diluent in there, 950 microliters, down the side of the cuvette so that it doesn't make any bubbles, and nice and slow. So again, carefully handling the cuvette so we don't put dirty fingerprints in the light path. We put it into the machine. The light path runs from top to bottom, and we then press the blank button to zero the spectro. Okay, we're now ready to make a dilution of our culture. So this is just a culture of E. coli in this case. And we're going to add 50 microliters of that into the cuvette. First, give it a bit of a mix on the vortexer to make sure it's evenly dispersed. And then check the pipette set to 50 microliters. And then we're going to use our yellow tip to get that into the cuvette. Now, one of the main issues we're going to have here is mixing, so making sure that that concentrated culture is mixed well in the diluent. And the easiest way to do this is simply just to pipette up and down several times, like 5 to 10 times, using that 50 microliter pipette setting. That should give enough mixing to give us a nice even suspension. Okay, again, note how carefully she's holding the cuvette, only using one set of sides and not the other two sides. Okay, we now press the green button to get a reading, and oh, this isn't good. So the optical density is greater than 1, so that means it's outside the accurate range of the spectro. So we need to repeat this using a higher dilution. So first we dispose of that culture into culture waste. We're going to get a new cuvette now, and we'll make a different dilution, which will hopefully be within the working range of the spectrophotometer. So this time we're going to use 990 microliters of LB broth as the diluent, and 10 microliters of concentrated culture into there. You can use many different things as a diluent here. You could use phosphate buffer, or you could use PBS. The main thing is that you need to blank the spectro on the same solution that you use to make the dilutions in. Okay, so there's our 990 microliters, so we're holding the cuvette by the left and right side, not touching the front and back side, and disposing of the tip into the sharps. Now we're going to blank. So of course we've taken a new cuvette from the box, it's good practice to make sure it's blanked again. Okay, so that's blanked at 0, and now it's time to add our culture. So because we're only going to add 10 microliters of culture, we face a bit of a problem here in mixing, because that 10 microliter volume is not so great for mixing up and down. So we're going to use one pipette to set to 10 microliters, that's 10.0 here, not 100. Use one pipette to add the culture, the 10 microliters, and then we're going to swap pipettes to a different one to do the mixing with, which is set to a higher volume. It's a bit hard to see there because it's a small volume, but there's our 10 microliters. Hopefully you can see it when it goes into the diluent though. There it goes. Okay, so we're now going to change pipettes. We'll swap over to a larger one that's set to 50 microliters. And we'll use that 50 microliter setting to suck up and down about 5 to 10 times to make sure that those cells are mixed evenly throughout the diluent. And into the spectro again, we press the green button to get a reading, and that's good. 0.13 is well inside the working range of the spectro, so we can use that to do our calculations with. First we have to dispose of our culture thoughtfully into the culture waste bottle, and then we can discard the cuvette. So it's now time to do our calculations. How do we get back from that reading to our original culture reading? So we use 10 microliters of culture into 1,000 microliter volume, total volume. If that's an OD of 0.13, what was the original culture? So one way to do this is to figure out what the dilution factor is. So in this case, the dilution factor is just 1000 over 10, which is 100. So the original culture is 100 times more concentrated than what we measured in the spectrophotometer. So to get that original number, we just multiply 0.13 by 100, which gives us an OD of 13.